Hai guys, kita sambung cerita kita tadi. Uh, Masih lagi bab yang kedua tingkatan 4, Forces and Motions. Okay, ini adalah subtopik 2.9, Analyzing Forces in Equilibrium. So we continue with question number 8. So now you are given two loads of mass 3 kilograms and 5 kilograms connected by a rope which passes through a smooth pulley. The system is released from rest, and you are to calculate the accelerations of the 5 kilogram load. Alright, so I have a load of 3 kilogram here and 5 kilogram here. Okay, 3 kilogram on the left, and on the right I have 5 kilogram. To which direction do you think that this system will be moving? I believe you can answer that question very easily. This part here is heavier, so definitely it will move. This thing will be moving down. Okay, this will be moving down, this will be moving up. Okay, and the acceleration must be the same. Why they must be the same? Because it is one rope, tali yang sama. So the tension in the rope is also the same. Alright, so how do we go about solving this problem? So first we analyze this. I have a load here, so I must have a weight going down. Okay, here is 5 times 10. Okay, W equal to mg, remember? So here I have 50 Newton. And here I have weight going down as well, and the weight here is 30 Newton. Okay, so let's call this as our W1 and W2. So how do we go about solving these problems? Okay, so we draw our free body diagram. This is the system. Okay, so I'm going to strengthen the rope. The 5 kilogram is moving this way. The 5 kilogram will exert 50 Newton. And then the 3 kilogram load, okay, the weight is going that way. Okay, so I'm strengthening this rope. Okay, so here I have a 30 Newton, and the system, it is going to the 50 Newton direction. Okay, so this is my resultant force. Okay, so it is going to the right, so this F must be positive, equals positive, I have 50 Newton minus 30 Newton. Okay, 50 is positive because it's going to the right, and then 30, I put here negative 30 is going to the left. Okay, but F equals to MA. So MA equals 20 Newton. But then what does this M refers to? Well, what is moving? 3 kilogram load and 5 kilogram load. So these two objects are moving. So the moving object in this system, okay, so my M here would be 3 plus 5. So my M here is 8 kilogram. Okay, so M is 8 multiplied by A, our acceleration equals 20. So A, okay, just plug it into your calculator. You should be able to get 2.5 meter per second square. Okay, that's how we solve this problem. Okay, we move on. I believe it's the last questions. Okay, 3 forces in equilibrium. So in these questions, you are given a block of mass 6 kilogram, okay, suspended vertically. Okay, suspended. This term, it implies that the system is in equilibrium. Okay, vertically by a string tied at O to the string AOB. Okay, if the system is in equilibrium, draw a vector diagram. triangle of forces, and hence determine the tensions of string OA and also OB. Okay, I have a force of this load. It is going down. Okay, it is going down. Okay, so if I put a dot here, okay, to represent the entire system, I have a force going down. That is my W weight. That will be 60 Newton. And then I have a force going this way. It's always going out from the dot, remember? Okay, going that way. And then I have a force going this way as well. And just follow the rope. Alright, so it's coming out from this dot here, the knot here. Okay, so first we draw a vector diagram. Alright, so let's call this as our T1 and this as our T2. There is no weight there, but we have the tension of the rope. The tension of the rope here is T1 and here is T2. And here I have weight going down of 60 Newton. Alright, so we are going to draw the triangle of forces. Alright, so I will start with my T2. Okay, T2 is going to the right. Okay, it's going here. Okay, maybe I just put here O, here is our B, so that you know where we are looking at. Okay, O and B. Okay, the force is going that way. Or maybe I should erase the alphabet there. Okay, so this is my T1. And then I have a force going down. So I'm going to continue from this point. It is going down. Okay, so here is my W, my weight. Okay, it's going down. And then from here, okay, I have a force going up. So this force is going up. Okay, so what force is this? This is our T1. What is the angle here? You see here? Parallel to this T1, right? Parallel to this one here. Here it makes 30, so here it must be 30 degree as well. So my W just now is 60 Newton. Okay, so I believe now you can solve for T1 and T2. Correct? Just use our trigonometry. So let's start with sin theta, sin of 30 degree. Sin equals to the opposite of the angle divided by the hypotenuse. So sin of 30 degree equals to our W divided by T1. Correct? So I want to find my T1 just now, right? So sin of 30 degree equals to 60. Okay, and then I divide it by T1. Hence my T1 equals 60 divided by sin of 30 degree. Okay, so that shall give you 120 Newton. Okay, so we are lucky here because here is actually a right angle. Okay, because this thing here is right angle, right? So simply lucky that we can simply use our trigonometry. So we have found our T1. What about T2? Where's T2? Oh, here is our T2. Oh, I mistakenly, oops. So here's my T2. Okay, how do I find my T2? Well, T2 is adjacent to the angle. So adjacent, we are going to use our cos theta. So maybe I just write here. Okay, so cos of 30 degree equals our T2 divided by our T1. Okay, so I have here cos of 30 degree equals to T2, and then T1 we have just calculated it 120 Newton. Okay, so T2 equals 120 Newton multiplied by cos of 30 degree. So you will end up with 103.9 Newton. Okay, so that will be the tension of string OA and OB. So that concludes our lesson for today.